So let's get going with this SQL for data analytics. So my plan is to first of all tell you what data analytics actually means, and just brush up the fundamentals of SQL, and then show you how you can do data analytics with the SQL. I have Most of you know me already that I've consulted in various product development, which includes data analytics products and consulting, and you can find me in LinkedIn. Right. So first of all, what is data analytics? I mean, all of us know it at the back of our mind, but we need to be very clear about what it is. So data analytics is a process of deriving insights from data. Right? It involves various techniques and tools for cleansing, organizing, and analyzing data to enable decision makers to make informed decisions. Right? So this is data analytics. And when we say data analytics through SQL or SQL, it is seldom that we are only using SQL. We are usually using some other tools in conjunction with SQL when we are doing pure data analytics. And I will get into that a bit later. But just a heads up about it. I will introduce you to a couple of more tools. So let's approach data analytics with one more definition. That data analytics is a process of examining data sets in order to draw conclusions about the information they contain. Okay, so you need to understand that there are two things here. One is information and one is knowledge, right? Information is the raw data that you have got. And knowledge is how you manipulate and interpret that data to come up with some facts, right? So that is knowledge. So data analytics is also a process of converting information to knowledge. Okay. So in business, data analytics is used to improve efficiency and effectiveness by identifying trends and patterns. Regarding the trends and patterns, we will do a small case study about it and how we can use SQL and some other tools to identify trends and patterns. Data analytics can be used to predict outcomes, optimize processes, and make decisions. So basically, the goal of data analytics is to help businesses make better decisions by providing them with knowledge and insights that they can use to improve their operations. Okay? And I'm sure all of you know SQL, but let's understand it from a definition point of view. So SQL, or Structured Query Language, is a programming language designed for managing data held in a relational database management system. So SQL is a programming language which is used in conjunction with a certain kind of database management, as a certain kind of database system, which is called Relational Database Management System, or RDBMS. So SQL is a standard language for relational database management system. SQL commands are used to perform tasks such as update data on a database or retrieve data from a database and manipulate the data. So some common relational database management systems that use SQL include MySQL, Oracle, Microsoft SQL Server, and IBM DB2. So whatever I will be teaching, because it is SQL, it's not dependent on a particular implementation of that of SQL. So whatever I'm teaching will be database management system agnostic, right? So it's not specific to say only MySQL or only Oracle or something like that. It's very general. So a typical RDBMS table looks like this, as you know. It is a two-dimensional table. It is always two-dimensional with rows and columns. And we have database schema, which means that in a database there are several tables, right? And those tables have certain relationship with each other. So database schema is a blueprint that defines the structure of a database. It includes the tables and columns that make up the database as well as the relationship between them. Okay. So this is the whole conceptual understanding you need to know is before we proceed. Right? So database schema are usually a bunch of tables and how they are related. Okay. So before we do analytics, we need to brush up some of the SQL commands. So for some of you, it may be a revision, and for some of you, it will be new knowledge. Through this command, we will also understand like what is the philosophy of this whole concept of this SQL language. Okay, so the simplest command or directive is select and from. Okay, so if you look at this particular query, so basically SQL statements are called queries. All right. So if you look at this query, it says select student ID, first name, first name, plus last name as full name from student. So lots of things are going on here, right? So the select part of a query determines which columns of data to show in the result, right? So there are columns and rows. So there are also options you can apply to show data that is not a table column. So even though selects particular column, but you can also have like artificial columns made on the fly, which is done in this particular query. So the example shows 3 columns selected from the student table, right? Student ID, first name, last name, and a calculated column. So the database stores the student ID, first name, and last name of the student. We can combine the first and last name column to create the full name calculated column. So the 4th column is basically what do you call it? A concatenation of first name and last name, and we give it a name to that calculated column called full name. All right, and this is how it might look like. So student ID, first name, last name, they're coming directly from the table. And full name is a calculated column, which is created on the fly. Okay. So this is select statement. And obviously there is create table statement. So even though create table is not directly concerned with data analysis, you will rarely use create table for it, because in data analysis, you will already be given the data. So perhaps you might create some new tables derived from other tables just to ease your process. So create table does just what it sounds like. It creates a table in the database. You can specify the name of the table and the columns that should be in the table, right? So when we say create table name can be student, let's say, and then column name. Column name may be first name, and then data type, like what kind of data. Is it a string? Is it a Boolean? Is it a float? So you have to specify that when you're creating a table, so that the system can allocate the memory accordingly. And then of course there is alter table, which means that there is already a table that you have already created and you want to alter it somehow. So if I say alter table name, add column name, data type. So let's say in a student database there is first name, last name, and then I also want to add a new column after the database is created, which is called marks, let's say. So I can say add marks, data type is integer. Okay, and then there is also something called check. So the check, what it does is that it creates a table and puts a constraint on it. So in this particular table, you can see that the check constraint is used to limit the value range that can be placed in a column. So if you define a check constraint on a single column, it allows only certain values for this column, right? So if you define a check constant on a table, it can limit the value in certain column based on values in other columns in the row. So in this particular example, the following SQL creates a check constraint on the age column. When the person's table is created, the check constraint ensures that you cannot have any person below 18 years old. So once you have created this table and someone is doing some data entry, and he enters an age which is, let's say, 15. So this table will refuse to add that particular record in its table because we have a predefined constraint on it. All right. So this can also help in data analysis because in the schema, once you see that a table has a certain kind of constraint, then you can use that knowledge to your advantage. So let's say if you're making a query, you already know that there won't be any age less than 18. So you don't have to consider that. So to allow naming of a check constraint, and this in this one, you will see that we have a constraint here. It allows naming of a check constraint, and for defining a check constraint on multiple columns. So you can use the following SQL for this. So what is happening here is that create table persons, ID, last name, blah, blah, blah. And then you say that constraint check person, check age more than 18 and city is equal to whatever, right? So you can put like multiple conditions on it, and it will put the constraints over there. Anyway, and now we are getting somewhere. All right. So before it was just preliminary thing, and now, for example, with where we can filter data, right? So the where clause is used to limit the number of rows returned. So as an example here, first we will show you a select statement and result without a where statement. Okay, and then I'll show you like then I will add a where statement that uses all 5 qualifiers above. So this is a very simple statement. Select student ID, full name, blah 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 from the table student. So it will give you all the records in this particular table. All right. And then what we're going to do is I'll repeat the same thing, but I'll limit the rows returning using a where statement. So what I'm doing here is that I'm doing exactly the same thing as before, but I'm adding a where clause here. And what I'm saying is that student ID between 1 and 5 or student ID is equal to 8 and SAT score not in 1000, 1400. So it will filter out any data which whose student ID is not between 1 and 5, right? And also not 8, right? As well as if the SAT score cannot be 1000 and cannot be 1400. So once we run this query, you will see this. So you can see the student ID 1, 2, 4, 5, 8, right? So it has to be between 1 and 5. So all these numbers are between 1 and 5, or it can also accept 8. So 8 is also there. And you see the SAT score, none of them are 1000 or 1400, right? As compared to this, right? Like, for example, student ID 3, it has SAT score of 1000, so it gets filtered out. Right? So we can get a filtered data by using where statement. Similarly, there is like update. Okay, update is in a way similar to alter because the difference is that alter alters the structure of the whole table, right? And update updates or alters only a particular record or a particular row, right? So this update, the syntax is something like this, that you update the table name and set column 1 is value 1, column 2 is value 2, where whatever conditions you are doing. So for example, what I can do is that, let's say in this particular table, right? I'm going to, the full name, I'm going to modify the full name and put a suffix, the grade. Whoever has SAT score of 1200 or more, right? So it is going to modify the, student ID 3. It will, it won't modify student ID. It will modify student ID 4. Yes. And because the SAT score is more than equal to 1200, and it will change the full name from Louis Ramsey to Louis Ramsey the Great, right? So that is update. It will do the same thing for 5 also, Alvin Green the Great, but it won't modify 1, 2, and 3, right? Because it don't meet the conditions. So, so that is update, right? So this is another one. So update person, set name is equal to Elton John, where ID is equal to 4. So what it will do is that if the ID is 4, which is Louis Ramsey, it will change the name from Louis Ramsey to Elton John. You can also update columns in a table by using values from other tables. So use a join clause to get data from multiple tables. So I'll get into join in more detail later. But for now, you can see that you can set, let's say there are 2 tables, right? And one table contains the names of the products. The other table contains the ID of the product. So we want to, like put the name of the product in table 1. So we can say that, table 1 dot name is equal to table 2 dot name from table 1 join table 2 on table 1 foreign key is equal to table 2 dot key. So foreign key is basically it's called the primary key. So for example, mostly the ID itself is the primary key, and you can connect it to a different table. So for example, one table may contain the sales of a particular product, and the other table may contain the details of the product. And you can connect the record of these 2 tables by joining the ID of both the products, right? So if you know the ID of this product, you know the sales of this product, and from the other table, you know the description of that product, right? So again, just update thing, no big deal here. Okay, group by is another thing that we can group certain things together. We can aggregate them. So the usual syntax is that select column name. Count star means it is one of the aggregate function. I'll tell you more about aggregate function in a bit. Where it just counts the number of rows. Count star means just counts the number of rows from particular table, group by column name. Okay, so if I just try to select column name, count star from table name, it will just count the total number of rows. But if I do group by, then it will count, but it will group by the column name. So for example, in this one, right? Let's go back to this one. If I say that select, if I say that select total, okay, just select SAT score, okay, from this particular table, and count star, select SAT score, count star from this table, and group by SAT score. So what it will do is that it will count the number of instances 400 has occurred in the table. So it will write SAT score 400, count 1, right? SAT score 800, count 1. SAT score 1200, count 2, because it has occurred 2 times. So because we are grouping by SAT score, it will count the total separately according to that group. So a group by allows you to combine rows and aggregate data, right? Also, you can having this, okay, having is another keyword, allows you to filter the data aggregated by the group by clause so that users gets a limited set of records to view, right? So here's the syntax of having, right? So basically, you do select column name, count star from table name, group by column name. And when you put having count star more than value, right? So in the previous thing, when we said, when we were grouping by SAT score, if you put the condition having SAT score, having count star more than 1, if I put that condition, right? Or having SAT score more than 800, right? So what it will do is that it will only display the counts of the SAT score which are more than 800. So it will only display 1200, count star is 2, 2400, count star is 1. So you can filter the group by stuff, the group by directive by the keyword having. Okay, average is just like count star. So you see count and average, these are what are called aggregate functions, which means that they do something in aggregate, like counts all these things, average counts and then divides by the number of, sums it up and then divides by the number of occurrences, right? So it's just like count star, you can say AVG and then num field, you can say. And also group by grouping field. So for example, in this one, if I do select student ID, full name, average, SAT score from student, group by student ID, full name. So can somebody try to predict what it will show in the table? Can somebody try to predict? Anyone? So to begin with, we are sure that it's going to show select a student ID and full name, right? And then that much we are 100% sure of, yes, from the student table. But it will also show average of SAT score, group by student ID and full name, right? So what does this entail actually? So it entails that it will select student ID, full name, and calculate the average SAT score, okay, of the student according to student ID and full name. And they will group by these two factors. Okay. And an as is more like allows you to rename a column or table using an alias, right? So this is more like a convenience kind of function or convenience kind of directive or statement. Is that I could, for example, in this case, select user only num1 as age of server, blah, blah, blah. And then user only num1 minus warranty period as warranty period from server table. So what I'm doing here is that I am taking data from server table and I'm selecting the column called user underscore only underscore num1. But this name of this column is kind of ugly, right? So I can rename. I can write as age of server, right? And then the second column it is displaying is user only num1 minus warranty period. So it's a calculated column, right? And I want to name that column non-warranty period. So you will get a nice looking table which will have a column called age of server, and you will have a column called non-warranty period. Okay, so as is more like a convenience kind of directive. Right? So it will look something like this. If you didn't do this, then age of server will just be called user only underscore num1 non-warranty period. Either it will throw an error or it will have a very long, ugly name. So it's not good for making reports, right? So that's why we use as. So, okay, this is a very long query. In this one, the query is that select order dot product. So or dot product means I am selecting a column called product from the table called ord, right? And I'm also selecting ord underscore number, price plus price, and cust name from a table called cust, and cust number from customer table, as cust join order table as ord. Oh, okay, so this is like a very mouthful, right? So in short, what I'm doing here is that I am joining two tables called order table and customer table. And I am renaming order table as ord. Okay. And I'm displaying this product, order number and price from order table, and customer name and customer number from customer table, with the condition that the customer number in the customer table is the same as the customer number in the order table. So there are two tables, customer customer underscore table and order underscore table. So both these tables have various fields, but they have one field in common. It is called cust underscore number. Okay. So what I'm doing is I'm joining these two tables with the condition that the customer number here matches the customer number there, right? In these two tables, I'm joining them, and I am when I join, so I get the product, order number, and price column from the order table, and cust name and cust number from the customer table. So now my final table will have 1, 2, 3, 4, 5 columns, right? That's all I'm doing. And only thing is that I'm changing the name of customer table as cust, and the changing name of order table as ord, because it is easier to write the query. That's all. I can use it even without using as. That's also okay. So it will look something like this, right? So 1, 2, 3, 4, 5, 5 columns, as I said. Yeah. Any questions so far? Okay. Now the second thing is, so far we have known, how to filter things, how to, select things, how to join things. Although I will go into join into more detail later. The next thing is order by. Order by is actually very simple, right? Even if you just read it, it will be very clear what it is doing. So order by gives us a way to sort the result set by one or more of the items in the select section, right? So here's a SQL sorting the students by full name in descending, right? So by default it's ascending, but if you want to sort something in descending order, you have to put the keyword DESC, right? So it will select student ID, full name, and SAT score from student. But instead of showing it according to the ID, it will arrange them in alphabetical order, in descending order of full name, and it will show likewise. So if you omit the keyword DESC, it will automatically arrange in the ascending order of full name. Right? So that is order by. So for example, I can also do things like select count star as student count from student. So, okay. So delete is also very simple. Delete from table name where whatever condition. So in this one, what happens is that let's say I want to delete all the students from the student table whose SAT score is less than 1,000, right? So I'll write delete from student table where SAT score less than 1,000. So it will delete all the records. So it choose, all the students whose SAT score is less than 1,000. Okay, so that is delete. So, but be careful using delete because you can delete all records of the table or just a few. Use a where condition to specify which records you want to delete. Okay. All right, now let's come back to the join statement that we have seen before, right? So there's several kinds of joins here. So a join is always between like two tables, and the default join is called the inner join, right? And in your high school, you must have studied the Venn diagram and stuff like that. So it's very clear that what it is doing here. So it selects records that have matching values in two tables. Okay. So let's say we have these two tables here, right? Or this is orders table, this is customers table, right? If we do an inner join, and it is usually like this. So the syntax is that select orders dot order ID customers dot customer name from orders, inner join customers on orders dot customer ID is equal to customers dot customer ID. So it is doing an inner join based on customer ID, right? So if we draw a Venn diagram of customer IDs, on one hand we have 2, 37, 77, and on the other hand we have 1, 2, and 3. So the only intersecting points between the two is 2. So the inner join will return only one record that is pertaining to customer ID, right? So it will give order ID and customer name, right? So order ID and customer name. So it will return a table which will have order ID 2, right? And customer name is Ana Trujillo Emperador is a Spanish name, not mouse. So that's the syntax. The select star from a.x joined by b.y on y.aid index. It is like this. So it is just like a select, but we are selecting from two different tables. Okay. So that's why we had to put a dot notation there to specify which table this particular column belongs to. And then we are saying from orders, inner join customers. So from table number 1, inner join table number 2. Right? And how we are joining it? We are joining it through customer ID. So that's why we write on orders dot customer ID is equal to customers dot customer ID. Okay. So that's inner join for you. And then there is left join, which is also very self-evident actually. So what does left join do? So So left join is like inner join, but it also contains all the entries in table 1, right? That's why it's called left join. Right? There's nothing called right join because you can always make right join into left join by changing the order of the table, right? So a left join returns all rows from the left table and the matched rows from the right table. The rows in the left table will be returned even if there is no match in the right table, right? The rows from the left table with no match in the right table will have null for right table values. Okay. So for example, in this particular one, right? So instead of inner join, if I did left join, you see, the syntax is left join, right? So instead of inner, I write left. So what will happen here is that first of all, it will take all the values on the left table, which is the orders table, and inclusive of the entry which is common. So it will just return, you know, three customer IDs, 2, 37, and 77. Okay. But you will see that for customer ID 37 and 77, there is no entry in the second table, the right table, right? So if I am doing select orders.order ID and customers.customer name from orders left join all these things. So you see that it has to show me order ID and customer name. Okay. So it will show me order ID and customer name for, no, sorry. Yeah. So it will show me order ID and customer name for customer ID 2. Okay. It will show me 10308 and Anna Trujillo, right? But for entries for customer ID 37 and 77, it will show order ID 10309 and 10310, but it won't be able to show customer name because it don't exist in the second table, right? So it will just give you null. So it will have 3 entries, order with 2 columns, order ID and customer name. And it will list order ID 10308, 10309, 10310, and customer name as, you know, Anna Trujillo, null, right? Because it doesn't have the information. So that is left join. Okay, and right join is basically just the opposite of left join. I mean, it is basically the same thing. You know, in left join here, you can write from orders inner. So from table 1, left join table 2 is the same as from table 2, right join table 1, right? It's the same thing. But it is convenient to have both, but you know. So a right join returns all rows from the right table and the matched rows from the left table. It is opposite of left join. This will return all rows from the right table even when there is no match in the left table. Okay? Rows in the right table that have no match in the left table will have null values for left table columns, just like before. So this is, you know, just a keyword. Instead of inner or left, you just put right. Okay, now the full auto join is, it will give you everything, right? So a full auto join returns all rows for which there is a match in either of the tables. So if there are rows in the left table that do not have matches in the right table, those will be included. Also, if there are rows in the right table that do not have matches in the left table, those will also be included. Okay. So for full outer join, so instead of inner join or right join or left join, you write full or outer join. Okay. And you can, like add on more keywords like order by. So if you put order by, then it will, order by this particular thing like customers.customer name. So it will arrange the data. Okay. All right. So joins are clear. Inner join, left join, right join, full outer join. And again, insert, it is just a command to insert new data. So insert into table name, the name of the column and values, whatever. So in that particular student table, I will say insert into student table, ID, name, score, values, 6, Anas, 1400. So it will just insert the values there. No big deal. It's nothing complicated. Now this is a useful one, the like. So in like, what happens is that sometimes you don't know the exact value, but you know a part of the value, right? So like is used where is used in a where or having to limit the selected rows to the items when a column has a certain pattern of characters contained in it. So in this one, so there is something called regular expressions. Regular expressions are a very different topic. I'll just write it down. Regular expressions, or also called regex. You can Google it. So basically in regex, it's like through certain symbol, you can represent a certain pattern, right? So this percentage symbol means it's a wildcard. So it means whatever. So if I say full name like Monique percentage sign, it means that Monique and whatever is after that, it will match it. So anything which starts with Monique, it will match it. And if I say full name like percentage green, it means that whatever green will match it, which means that anything that ends with green will match it, right? So this SQL will select students that have full name starting with Monique or ending with green, right? So and the syntax is select, whatever column you want to select from table name, where you put, column name like this or this, right? But instead of or, if you had put and, then it will only return those full name which start with Monique and end with green, right? So that's the difference between and or. These are called conditional operators. So you see Monique Davis fits the pattern of Monique percentage, and Alvin Green fits the pattern of percentage green, right? So that's why it returns these two rows. Okay. Also, you can place not before like to exclude the row with the string pattern instead of selecting them. So this SQL excludes records that contain Sir, Pao, and Ted in the full name column. So sometimes you want something to not fit a pattern. So you can put the keyword not. So in this one, you will see that Monique Davies is not like Sir, Pao, and Ted. So it returns, right? So if you want to return things which do not match a pattern, you can put a not keyword in, and it will do so. Okay. All right. So the basics are done. Now let's move further. Let's talk about tooling. All right. So as I said before, usually the SQL, the data analytics in SQL is usually done in conjunction with some other tools. Okay. So one of those tools is called Azure Data Studio, and it It can be Azure Data Studio, or it could be, Python programming language with libraries like pandas and matplotlib. So you use SQL with these kind of other technologies. So let me introduce to you Azure Data Studio. It's a very cool technology and database tool. Azure Data Studio is a free and open source data management tool that enables you to work with SQL Server, Azure SQL Database, and Azure SQL Data Warehouse. It provides a user-friendly interface that allows you to connect to your databases and run queries, create and manage databases, and import and export data. Okay. Azure Data Studio also supports extensions that enable you to extend its functionality. So we will explore this tool a little bit. So even though it says that it enables you to work with SQL Server, Azure SQL Database, Azure SQL. So Azure is like a cloud component of Microsoft, right? But it doesn't need to be Microsoft product or Microsoft implemented SQL Server. It could be just MySQL also. It can connect to MySQL Server as well. It can also analyze flat files like CSV files, like comma separated files. Okay. So you can do all those things with Azure Data Studio. So for example, over here, so this is a CSV file, as you can see, right? And this one is just basically an item. So the column names are item identifiers, item weight, item fact content, item visibility, so on and so forth, right? And then you can see a list of data or list of records in that CSV file. Okay. So we can just drop the CSV file in Azure Data Studio. And it uses extensions. Actually, let me show you actually. So this is Azure Data Studio, right? So if you look at, this is a CSV file that I've dropped in Azure Data Studio, but it need not be a CSV file. It can be a query. It could be the result of a query, right? So for example, you do a query, select star from customers, and the result of a query would be a table. So you can use that table in here. You can make a query, and then you can use, okay, in Azure Data Studio, there's something called extensions, right? Extensions can do lots of things for you. So Azure Data Studio comes like a bare bone, but you can customize it according to your needs. So for example, if you are into machine learning, you can, like install a machine learning extension to it, and you can do stuff with it. What I have done is that I have installed extension called Senddance. All right. So as you see here in the description, you can just click and install it. Visually explore, understand, and present your data. Okay. So it is showing you by using easy to understand views, Senddance helps you find insights about your data, which in turn help you tell stories supported by data. Build cases based on evidence, test hypotheses, dig deeper into surface explanations, support decisions, and so on. So you will see that if you actually look at this video, it made a query, and then using Senddance, it's able to explore the result of that query graphically. You see, this is a query, right? Select blah, 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 and then you got a table and you got a graphical representation of it. So I'm also going to do the same thing. The way you do is that in this one, I right click on it and then go to view in Senddance, right? And I immediately get transported here. So you can explore all kinds of charts here. Right? You can explore bar chart. Actually, first of all, let me remove this. Okay, cool. So this is like a bar chart, or a column chart would be better. So I can rotate it, right, like this. I'm just left key, I'm pressing control and then using mouse left click to rotate like this, right? And if I don't press control, you can move it around. Okay? With control, you can rotate it, right? So this is a column, right? So what is this about? Okay, you can zoom in and zoom out by the scroll, your mouse scroll. Okay, so if you look at the data here, what it is showing you is different categories of data and the count. Okay, so low fat, lowest fat maybe LF. I don't know what that means, but there are few categories: regular and two kinds of low fats and two kinds of regular. So if you actually look at the data here, if you look at item fat content, right? So item fat content over here, you will see that 1, 2, 3. So it is low fat, regular, low fat, low fat. So what it is doing is it's showing you the it's showing you the count of those categories. So low fat has the highest count, right? And also it's showing you some more stuff, like it's showing you like, okay, if you look at it, x-axis is this color by item MRP, right? So if the MRP is maximum retail price, right? So if the maximum retail price is less than 63, then it is red, and so on and so forth. If it is more than 220, it is green. So you can see that if we zoom in, you can see that actually the low fat, it is equally distributed between different MRPs, right? If you go to regular, you will see that it is a bit more biased towards lower ones and so on and so forth. You can even do like a stack. So what stack is doing here is, so you see here, it is like a three-dimensional graph. So this is the categorization of the data, and this is the count, right? And this is the item fat content. Okay, both are the same. Let me change it. Y-axis would be item weight. Yeah. Yep. So you see the way the data is distributed is that this represents, this particular view represent, the one that you have seen before, the categorization and the count. And then this view, so this is the item weight over here, right? If I just move it like this, so this is the item fat versus item weight. Okay. So you can see like a 3D representation of all these things. And you can even subcategorize it. So for example, I had this column thing, right? So I can do something like facets. Facets is like, say, item type, right? So now I have the same graph, but classified or chopped down into different item types, right? So you will see that so here you will see that health and hygiene products, they are highest in this particular category, right? And then, so you can see the distribution over here. And actually, if you just zoom in, you can just hover over a particular data point, you will see all the details of that data point as well. Okay. So you can do like lots of things there. All right. So this is Azure Data Studio, and you can do like visual analysis of data using SQL and this. So SQL With SQL, you get like some kind of table, whatever table you want, a filtered table using all the queries I told you, select queries, join queries. So once you get the table, you can see a visual representation of the data of that particular table, yeah, using Azure Data Studio. Okay. So you can do all those things. Yeah. So as I said, it has extensions. You can easily do these kind of things, and you can right click on the result, the table or the CSV, and once you've installed Senddance, it will show in your drop down, and you can see all these things over here, whatever I showed you, right? So this was visual analysis of data, right? We will do more visual analysis, but a bit more sophisticated one, more sophisticated than a histogram or a bar chart or a three-dimensional bar chart with 3 variables. We will do something called time series analysis. Okay. There's actually, in analysis, there are many kinds of analysis, but I'll focus on this one because time series analysis is most often used. So for example, stock prices you analyze stock prices through time series analysis. So what is time series analysis? So time series analysis is a statistical technique that is used to examine data points that are collected over a period of time. Right? This type of analysis can be used to identify trends, seasonal patterns, and relationship between variables. Time series analysis can be used to make predictions about future events based on past data. Right? So this time series analysis is one of the most common types of analysis done with SQL. So a time series is a sequence of measurements or data points recorded in time order, often at regularly spaced intervals. Right? For example, stock prices or the temperature during the day, the average temperature every day, that is also time series because it's like the time is moving forward, right? So, and there are many examples of time series in daily life, such as high temperature or closing value of S&P 500 stock index, or the number of daily steps recorded by your fitness tracker, right? Time series analysis is used in a wide variety of industries and disciplines. Okay. So it is used in statistics and engineering as well. It is used in weather forecasting. It is used in business planning. So time series analysis is a way to understand and quantify how things change over time. And there is some level of predictability in time series. So, for example, if you're using an Apple Watch or whatever, it has the number of steps that you walk every day. So it can kind of predict that, okay, next day, approximately how many steps you're going to walk. So in order to do time series analysis, you have to actually, in any data analysis, the first thing that you need to do is to shape the data in a usable format, right? So for example, you may have a time series analysis data, but the date and time are haphazardly distributed, or they're not in the right format, or they're not in the form that you can use for time series analysis. So we need to do some kind of manipulation. Okay, date, time, and time manipulations. So by time manipulations, I don't mean time travel, but like the manipulation of the time data. So dates and time come in a wide variety of formats, depending on the data source. Right? We often need or want to transform the raw data format for our output, or to perform calculations to arrive at new dates or parts of dates. Let me give an example. The data set might contain transactions timestamps. Let's say, there is some mall and there are transaction timestamps. But the goal of analysis is to trend monthly sales, right? Let's say I want to, see a trend of month to month, but your data is like daily or even hourly, right? Or at irregular intervals. On day one there is 5 data, on day two there is 6 data. So or at other times we might want to know how many days or months have elapsed since a particular event has happened. Okay? So fortunately, SQL has powerful functions and formatting capabilities that can transform just about any raw input to almost any output we might need for analysis. Okay? So one of the things, one of the facets of time manipulation is time zone conversion, right? So for example, you might be getting data from different places, right? And their time zones might be different. But you want to, have a standardized set of data in the same time zone. So you can do something called time zone conversion. So it's a process of converting a local time to another time zone. Okay? And understanding the standard time zone used in a data set can prevent misunderstanding and mistakes further into the analysis process. Time zones split the world into north-south regions that observe the same time, as you know, and time zones allow different parts of the world to have similar clock times for daytime and nighttime, right? So, for example, the sun is over at 12 p.m. wherever you are in the world. Okay, the zones follow irregular boundaries that are as much political as geographical ones, right? So most are 1 hour apart, but some are offset only by 30 or 45 minutes. So, and so there are more than 30 time zones spanning the globe, right? Many countries that are distant from the equator observe daylight saving time for parts of the year, like the US, right? And each time zone has a standard abbreviation, such as PST, which means Pacific Standard Time, or PDT for Pacific Daylight Time, and so on and so forth. So you can easily do time conversion, simple time conversion. So for example, select a particular timestamp at time zone PST. So it will automatically convert that time into PST, right? So, so all local time zones have a UTC offset, right? So for example, the offset for PDT is UTC minus 7 hours, right? Does anyone know the offset for Malaysian time? It is +8. Okay. So the time difference between PDT and Malaysian time will be minus. So 8 minus -7 is 15 hours. Right. So timestamps in databases are stored in the format YYMMDD. Okay. So years come first, months come second, and the date comes third. So timestamp with the time zone have an additional piece of information for the UTC offset. Okay. So expressed as a positive or negative number. Okay. So whatever the time stamp is, it comes with the offset as well. So that's why it is very straightforward to convert time zones. So converting from one time zone to another can be accomplished with at time zone followed by the destination time zones abbreviation. For example, we can convert a timestamp in UTC that is offset 0 to PST like this. So -0 means the offset is 0, which means it is UTC. Okay. So we know that we are converting a time which is at offset 0 to a time whose offset is -7. Okay. So the destination time zone name can be a constant or a database field, allowing this conversion to be dynamic to the data set. So this is a very simple way to do a time zone conversion. And the next thing is date and timestamp format conversions. So you can easily get current date by just saying select current date. Okay. So dates and timestamps are key to time series analysis, right? So due to the wide variety of ways in which dates and times can be represented in source data, it is almost inevitable that you will need to convert date formats at some point, right? So in this section, we will cover the most common conversions, but we won't go too deep into it. But only some of the things which are useful for the case study I'm going to show you. Okay, so this is simple. It selects current date, and then there are a wider variety of functions to return the current date and time. Okay, so you can check your database documentation or just experiment by typing into a SQL window to see whether a function returns a value or an error. The function with parentheses do not take arguments, but it is important to include the parentheses. So current timestamp may, give you date in the timestamp in a certain format. Then now will give you it in a different format, so you can check it with different database vendors. They have slightly different way of implementing it. Finally, there are functions to return only the timestamp portion of the current system time. So again, consult the documentation to see the. So for example, the time of day will just give you the time of the day, so on and so forth, right? And then there is extract. Extract takes a part name and a date or timestamp value and returns a float value. Okay. So if I do select extract day from current timestamp, so it will go to the timestamp and it will extract the date part from it. Okay. And if I do extract month, it will extract the month part from it. Okay. If I select extract hour from current time, it will only extract the hour, because sometimes we don't want the whole data, because let's say we are doing some kind of calculation based on the hour, right? Then if you don't extract it, we'll have to take the whole shebang and then manually, like programmatically extract the hour. So it's very cumbersome. So SQL has these helper functions for you that you can just extract whatever you want from the current timestamp or any kind of timestamp, actually. Sometimes analysis calls for creating a date from parts from different sources, right? So this can occur when the year, month, and day values are stored in different columns in the database. It can also be necessary when the parts have been parsed out of text. Okay, so this is the opposite of what we did before. Before we were like extracting a part of some big timestamp. Here we are doing the opposite. We are actually putting together the different parts of the timestamp together. Yeah. Okay, so date math means what you do with the mathematics of dates, right? So date math is the process of adding or subtracting dates in order to calculate a new date or an interval, right? So for example, this one, right? First, let's find the days elapsed between two dates. So I can simply do select date this minus the date that as days, right? So what it will do is it will take 2 days and give you the difference between them in terms of days. Okay. You can also do it in terms of hours or whatever. All right. So the easiest way is to use a mathematical operator. Right. So even though date itself is not a number, but SQL can do this kind of manipulations. Right. But you have to tell SQL that this particular thing, this particular string, that is 2020-06-30, this particular string is a date. You have to tell SQL. So then it will treat it as a date rather than a string. So it will take two dates and subtract them. So and then we might have to join data from different sources. Okay. So combining data from different sources is one of the most compelling use cases for a data warehouse. However, different source systems can record dates and times in different formats or different time zones, or even just be off slightly due to issues with the internal clock time of the server, right? So actually one of the biggest work in data analysis is data cleaning. So if you have data from different sources, you have to, make them uniform and convert one kind of data into another kind of data so that you're able to do analysis on the aggregate of all the data. Okay. All right. So now let's come to an actual case study here. So the case study is a data set of monthly US retail sales from monthly retail trade report. Okay, let me give you a link where you can actually find this data. It is open data. Find it. We'll be using this data. So instead of going through it yourself, let me just show you a snapshot of how the data actually looks like. So you'll see that there are 1, 2, 3, 4, 5. Total of 6 columns. One is the primary key, the serial number, but there are basically 5 columns other than the primary key, right? So one, we have the sales month, okay, and then the code of that particular item, then the kind of business, right? The kind of business could be motor vehicle and parts dealers or automobile dealers or whatever. A reason for null, just don't worry about it. And then we have sales. That's important data. So the most important columns here are sales month, kind of business, and sales. Okay. So what we are going to do here is trending the data. So with time series data, we often want to look for trends in the data. So this is the simplest and actually most effective time series analysis is trend analysis. Yeah. So a trend may be moving up or increasing over time. It may be moving down or decreasing over time. It can remain more or less flat, or there could be so much noise or movement up and down, like the crypto prices, they're very volatile, right? So there's too much noise. And if there is too much noise or volatility, then it's hard to determine a trend at all, right? So we are going to cover several techniques for trending time series data, from simple trends to more complicated trends. So let's get to it. So simple trend. Okay. So remember that data. So all throughout we'll be using this table. Okay. So the name of the table is retail sales. We are selecting sales month and sales. Okay. But where kind of business is equal to retail and food services sales total. Okay. So so kind of business should be retail. It's not here, but further down it is there somewhere. So it will only give you the sales month and sales of the rows where kind of business equals this. Okay. We have sales here, right? Month to month, all the way from 1992. 14637 blah 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 blah. So so creating a trend may be a step in profiling and understanding data, or it may be the final input. So maybe the trend graph may be the final result, or the trend data may be an intermediate data for doing something more complex. So the result set is a series of dates or timestamps and a numerical value. Okay. Usually the time series trends are dates and some numerical value. In this case, it is sales. So when graphing a time series, the date or timestamps will become the x-axis, and the numerical value will be the y-axis. So, for example, here we can check the trend of total retail and food services sales in the US. So this particular query returns a table, right? And as I said before, once you have the table, you can use various tools to graph it. So if you're using the Azure Data Studio, you can make this query and get this table, and you can see the graph of that table in Azure Data Studio, like this. So you can see here the graph is, it is, you know, month to month, right? And the, you know, not all the dates are written here because otherwise it would be very cluttered. And then sales in millions, right? So you will see that the data is going like this. Data is clearly has some patterns, right? But it also has some noise. So transforming the data and aggregating at the yearly level can help us gain a better understanding. So maybe breaking it down into monthly sales is will contain too much noise. So what we're going to do is we are going to group the data on a yearly basis rather than a monthly basis. The monthly basis is the default. That's how the table comes. So what we're going to do is we're going to group it by year. So what we're going to do here is we're going to do select date part year in sales month, okay, as sales year. Right. So if you look at this data here, the sales month has 99211, right? So we are just extracting the year part there. And then what we're going to do is we're going to sum all the sales within that year. So we're going to say sum sales as sales. So this sum sales, so the column name will be called sales from retail sales, which is the name of the table, where kind of business is equal to retail and food services sales total. And then we say group by one. By one here means the index of the column number. So the first column. So group by one means group by sales year. Okay. So it will take all the data and then sum it up according to the year, right? So first we will use the date part function to return just the year from the sales month field and then sum the sales. Okay, and after the summation, the results are filtered to the retail and food services sales total kind of business in the where clause. Okay, and then now when we draw the graph of this particular one, we are going to get this. Okay, now we are going somewhere, right? So if we graph year to year, after graphing this data, we now have a smoother time series that is generally increasing over time, right? As might be expected. Okay. Since the sales values are not adjusted for inflation, sales for all retail and food services fell in 2009, right? Because in general, the prices fell, right? Because there was a crash, remember, in 2009. So the prices crashed. So it was into 2009. Therefore, you can see that here over here, there's like a fall that was during the, during the global financial crisis. So after growing every year throughout the 2010, sales were flat in 2020 over here. Can somebody tell me why the sales were flat in 2020? What happened in 2020? So graphing time series data at different level of aggregation, such as weekly, monthly, yearly, is a good way to understand trends. Okay. So this step can be used to simply profile the data, but it can also be the final output depending on the goals of the analysis. Next, we are going to we'll use SQL to compare components of a time series. Okay. So comparing components. So often data sets contain not just a single time series, but multiple slices or component of a total across the same time range. Right? Comparing these slices often reveals interesting patterns. So let's have a look at our next query. What is doing here is that select date part as sales year, kind of business, sum as of sales as sales from retail sales, we're kind of business in bookstores, sporting goods stores, hobby, toy, and game stores, grouped by 1, 2. So what we are doing here is that we are, unlike the last part where we were only interested in one kind of business, we are interested in a few kind of business. We're interested in bookstores, we're interested in sporting goods, hobby, toy, and game stores. Okay, so we want to have year-to-year sales data, some year-to-year sales data of all these groups, and they're grouped by 1, 2, which means that they're grouped by column 1 and column 2. So column 1 is sales year and column 2 is kind of business. Okay, so it means that it will add up the sales of all the sales of hobby, toy and game stores in the year 1992, then sum up all the sales from hobby, toy, and game stores in the year 1993. Similarly, sum of all the sporting goods stores in 1992 and 1993. So it will group by both the columns. Okay. So that's why you will see here that the sales year, it is 1992 repeated several times because it is repeated for each category. Right? They're grouped according to each category. So, so if you look at, if we draw the graph of it, we will see something like this, that we have sales of hobby, toy, and game stores that are going up and up. Sales of, sporting goods stores, they're going up and up. Then hobby, toy, and game stores, they are like kind of stagnating, and bookstores, they're actually going down, right? So sales at sporting good retailers started the highest among the 3 categories and grew much faster during the time period, right? And by the end of the time series, these sales were substantially higher. The sales at sporting goods stores started declining in 2017, but had a big rebound in 2020, right? Sales at hobby, toy, and game stores were relatively flat over the time span, with a slight dip in the mid-2000s and another slight decline prior to a rebound in 2020, right? So sales at bookstores grew until the mid of 2000s and have been on the decline since then. So all these categories have been impacted by the growth of online retailers, but the timing and magnitude seem to differ, right? Obviously, people started reading books more and more online through Kindle or whatever. So the bookstores, their sales went down, obviously. So now what we are doing is, so if you look at the query, in the next query, in addition to looking at simple trends, we might want to perform more complex comparisons between parts of the time series. So we will look at sales at women's clothing stores and at men's clothing stores. So here what we're doing is select sales month, kind of business, sales from retail sales, where kind of business in either men's clothing stores or women's clothing stores. Okay. So we have sales month and all these things, and let's graph it out. When we graph it out, we see this, right? So obviously the data is very choppy, isn't it? The results are graphed here. Sales at women's clothing stores are much higher than those at men's clothing retailers. So both types of store exhibit seasonality, right? That's why they are like a heartbeat, right? So both experienced significant drops in 2020 due to store closures, right? and a reduction in shopping because of COVID-19 pandemic. Right. So let's analyze it a little bit more here. So we are going to do this. So this monthly data has intriguing patterns, but is noisy. So we are going to use, yeah, it looks like cardigan. That's correct. Exactly, because of seasonality, right? So, so we will use yearly aggregate. Data, and then what in this particular query, what we're doing is the same thing. We are selecting the date part and kind of business, and sum of sales according to year from retail sales, where kind of business in either men's clothing or women's clothing, and improved by 1, 2, right? So 1, 2 is what? 1, 2 is the date and the kind of business, right? So if you look at the yearly one instead of the choppy one, the monthly one, we are looking at yearly one, so it's more smooth. So it shows you the trend more clearly. So are sales at women's clothing stores uniformly higher than those at men's clothing store? Right. I mean, obviously, women's clothing store is like way higher, like more than triple actually than men's clothing, right? So women buy 3 times more than men in terms of clothing. So the question I was asking is, are sales at women's clothing stores uniformly higher than those at men's clothing store? So if you look at the yearly trend, right, the gap between men's and women's sales does not appear constant, but rather was increasing during the early to mid 2000s, right? So the gap, if you look at this gap over here, right, it was increasing from during the early to mid 2000, it kept on increasing. So women clothing sales in particular dipped during the global financial crisis, right? And sales in both categories dropped a lot during the pandemic in 2020, right? So, from mid 2000s to 2009 till the financial crisis, and the gap between the women clothing and men clothing kept on increasing until the financial crisis happened, and then the gap kind of became constant, and then there was like a sharp decline due to pandemic. So you can see that so what can you say about this, just looking at it? If the gap kept on increasing but remained constant after the global crash, it probably means, I'm not sure, it could probably means that women were buying clothes through credit a lot, right? But after the crash, there was not much credit left, so the gap became constant, and it just fell, after the pandemic. So we don't need to rely on visual estimation, right? However, for more precision in this gap, you can calculate the gap between the two categories. So you see the gap that we were having here, we can actually represent that gap with some numbers, x minus y. We can calculate the gap between the two categories, the ratio, and the percent difference between them. So to do this, the first step is to arrange the data so that there is a single row for each month, okay, with a column for each category, pivoting the data with aggregate functions combined with case statements accomplishes this. Okay, so again, you don't have to really be a master of SQL, but in this, what we are basically doing is that select date part, okay, as before, sum case when kind of business is this, then sales end as women's sales. So we are going to sum all the sales under women's clothing and put it under the column name called women's sales, right? We do the same with men's clothing and put it under men's sales, right? So we get a side-by-side comparison of sales of women's sales and men's sales year to year, right? So, and then we can do more complex thing that instead of just showing two columns, we can do women minus men or men minus women. Both are, one is the opposite of the other, right? So now here you can see the gap. The gap keeps on increasing and then slight dip over here in 994. So you can see all that. You can actually graph the gap and see what's the trend in that. So in this one, with this building block calculation, we can find the difference, ratio, percent difference, all those things. So difference can be calculated by subtracting one value from the other using the mathematical operator minus, right? You can simply do that, correct? Yeah, so we can find the the gap over here. So we don't need men minus women because it is exactly the same as women minus men, but opposite sign, right? So we construct this query, and then we are going to get this women minus men, and then we are going to make a graph of it. There you go. So remember, it is women minus men, not men minus women. So women minus men means women are buying so more and more since 2000s. The gap is increasing, except for this part, and it became stagnant. It was actually decreasing from somewhere between 1993 till 1997. It was decreasing for some reason. I don't know why. So when you see these kind of anomalies and you think that what exactly happened, then you look at the data and you do data analysis. It gives you insight. It gives you ideas what to look for, right? So now you see that for some reason the gap was decreasing in this particular region. Then you find out what exactly happened, right? And then when you find out what exactly happened, then you can find more complex marketing strategies, sales strategies, with the new knowledge that okay, these factors affect sales, or these factors don't affect sales, right? So you can do all those kind of things. Now now what we're doing is instead of difference, we are taking the ratio, right? So the ratio also looks something like this. If we plot the result, the trend is similar to the difference trend. But while there was a drop in the difference in 2009, the ratio actually increased. So what does it mean? That there was a drop in difference, but increase in ratio, right? It means that even though the gap decreased, it did not decrease like fast enough, So you can do different kind of analysis by having ratios or differences and see like some anomalies in the graph visually, and then you can investigate those anomalies. Okay. So again, basically this one is just the same as ratio, but in percentage, right? So although the units for this output are different from those in the previous example, the shape of the graph is the same as that of the ratio graph. Its choice of which to use depends on your audience and the norms in your domain, right? So all of these following statements are accurate. If I say that in 2009, sales at women's clothing stores were 28.7 billion, higher than sales at men's stores, right? Or I can say in 2009, sales at women's clothing stores were 4.9 times the sales at men's stores. Or I can say that in 2009, sales at women's stores were 390% higher than sales at men's stores. So which version you select depends on the story you want to tell with the analysis, right? So this analysis has two parts, right? One is to find insights, and the other is to present the knowledge to the management or whoever, the insights, to present the insights. So how you present the insights depends on your use case. Okay, so this is a small, like a taste of the SQL analysis that you can do. And remember that SQL analysis, it's not just about, I mean, of course, you can say that, I can do SQL analysis just by writing SQL statements. Yes, you can do that. You can look at the numbers, but you need some kind of graphing tool to visually spot anomalies, right? So it's good to use some kind of graphic tool with it. Graphic tool could be Azure Data Studio, and if you're into programming, then you can use Python and pandas libraries or matplotlib libraries, which is a graphing library for Python. So let me just write it down. So Azure Data Studio, and we have Python, we have pandas library, we have matplotlib library. So you use SQL with conjunction with this kind of tools. Okay. So with that, I will just end this presentation.